All right. Thank you, everyone, for joining this EDX webinar. Wi-Fi is one of the largest and fastest growing technologies globally and is the key to bridging the digital divide in developing countries. And this technology is evolving to meet these user demands. So we are excited to announce our new Wi-Fi module. And in this webinar, we're going to cover those feature sets that will model, plan, and optimize your Wi-Fi networks. And for this, I'm going to pass this over to Brian Jones, who's going to share his screen and then walk us through his project. Brian.
Hey, Rory, thanks. Can everybody see my screen okay? Or is potentially the text really small?
We can see it, but yeah, the text is a little small.
Sorry about that.
We're using one of those ultra widescreen monitors, right?
Yeah, I apologize, everybody. Let me just back this off a little bit. We'll go to something like that. Is that a little better, Rory?
Yes, I can switch back to my regular glasses now.
Okay. So I wanted to kind of just give you an overview and take a look at a couple examples real quickly. We won't do too much of a deep dive into anything here today, but if you have deeper questions or want to look at a real particular use case, I do encourage any of you to reach out to us either through your contact in sales or the support team. If you've got a use case for Wi-Fi that you're looking at and you'd like to schedule a customer success session and sort of talk through that, I'd be real interested to see what you're working on and help you get that set up. So to look at the new Wi-Fi module, there's we've supported Wi-Fi for a long time under our WiMAX broadband module, and really what we've done with the Wi-Fi module by separating that out, we've simplified the setup a great deal, and also added a lot of new features and added support for the latest revision of Wi-Fi and et cetera. So let's take a look first at sort of how I would set up the project for a standard outdoor project. And what I've got here is a little hypothetical piece for broadband delivery to homes, like to rooftops on homes in the Portola Valley, where not only do we have a lot of elevation change, but we have a lot of trees potentially obscuring those home rooftops. And the first thing I always want to throw out there and mention for that use case is the availability of really high resolution and high detail land use and land cover data. What I'm using right now is just our regular 5-meter subscription data, which is a 2D data set. But if this, I could do my initial dimensioning of the project, for example, do some estimates with this data. And then if I won that project, I might seriously consider getting some custom clutter data with measured clutter heights, which is now available at a variety of resolutions for really cheaper than it's ever been. And so for each grid cell within the clutter data, you have a measured height for the trees or buildings or whatever, so that if you're trying to determine where you have line of sight to building rooftops, you have a much more reliable data set and much more accurate picture of the heights of all those trees right in around the houses. And you can get that at really surprising resolutions too. I think there's 2-meter, 5-meter, and 10-meter, depending on what your needs are. So I've set up my propagation model, and because I'm looking, in this example, I'm looking at 5.8 gigahertz specifically, I wanted to isolate that band and look at the coverage. And so I'm using the add clutter height to terrain height so that any of those treetops would be treated as a fairly solid obstruction that you have to diffract over. And then I define my equipment in, you know, the usual way. I can set up my template for what a site's going to look like, set up all the link budget parameters. If you're doing dual band Wi-Fi, if you've got both 2.4 and 5.8 gigahertz, you can just put both of those on as their own sectors on the site. And then, of course, I've selected the system type of Wi-Fi, and I select a MIMO adaptive antenna. In this case, I went with something sort of moderately fancy, an 8x8 MIMO B. We support all kinds of crazy MIMO configurations. And importantly for Wi-Fi, we support this BSSID that you can import along with all of your site details. So if you've got a real network out there in the field and you've got that BSSID for each access point, then you would import those. And one of the new features that we have is a BSSID conflict search function and conflict resolution dialog. And I'll show you that here in a minute. So I set up my basic site template with all my link budget parameters and everything, just like you would set up any site in Signal Pro. And then under network design analysis, Wi-Fi networks here, the first thing I do is just define the Wi-Fi system profile that I'm working with. In this example here, I'm using 802.11ac with a 20 megahertz bandwidth. I think that's what I'm set up for. And I also select an adaptive modulation chart here, which basically correlates the signal to noise ratio that you need to reach each coding level, each modulation type, and then what the deliverable data rate would be for each of those different modulation types. And of course, we keep track of that on the uplink and the downlink. And then I can point to a channel plan template file here, which, you know, we include the typical ones here for 2.4 gigahertz or 5.8 gigahertz or combined. The 6 gigahertz channels and channel plan template aren't included in the install yet, but you can build your own custom channel plans to include whatever you want. So there's no problem there. I've also pointed to this service area boundary file, which is just the blue polygon you see. That's the theoretical area I'm trying to cover. And so having defined the link budget parameters on my access points and defined the technology, I can then set up either a mobile remote unit if I want to do sort of area-wide coverage studies, such as this here. This is a downlink data rate area study, just using a mobile unit that's set up at the same height as a rooftop antenna would be. But of course, maybe that works for initial sort of estimate purposes, pre-dimensioning. And then the next stage of the project, maybe my customer sends me a list of actual pre-subscribed customers to be served, or fixed points of some kind that we want to make sure we have coverage to for whatever our use case might be. And so I can set those up as a CPE or customer premise equipment. So I set myself up a rooftop subscriber and all of its link budget parameters. And then I can import those through the spreadsheet editor as well. I can just go ahead and, bring in a bunch of latitude, longitudes. And importantly, they could each have different heights above ground level. So if the installers have been out there, put a mast on the roof, and you have an actual height for that antenna, then we can put those in explicitly for our customer terminals, and the point to multi-point studies will treat each one as its own path profile, again, so that you get a nice, accurate, precise prediction to that rooftop. And now in this example that I'm showing here, I've already got some access points loaded into my project. But one of the really key features that you get, especially for if you have a large scale design that you need to do in Wi-Fi, one of the really great features that we get either for area wide or fixed point to multi-point cases are the automatic site placement tools. And if you have the Wi-Fi module, then you get those automatic site placement tools both for area wide. So in other words, I can define the template for what my access point looks like, and then go to databases, towers, and poles, and specify a list of basically all of my candidate tower sites. So all of these little blue dots here represent a location where I could mount an access point. Maybe these are utility poles or street lights. They can be actual cell towers. And one of the great things about our tower and pole database format is that this supports not only the location and height of the mounting assets, but also relative cost factors. So if some of your locations are more expensive to deploy on than others, you can include that as part of the database. And when I do my auto placement function, it will, I set the coverage threshold that I need and the percentage of the area that I'm trying to cover. And the software will go through and recommend which of those candidate sites should be used to cover the percentage that you've asked for. So I can go through and basically convert some of these candidate sites into actual APs, and it'll just automatically create all those sites on those locations at the appropriate height. And we can do that for an area-wide type of network, or we can do that using those fixed CPE customer terminal locations. If I go under network design and multi-point backhaul networks, this create hub and transmitter group, this is also automatic site placement, but it uses just those fixed subscriber locations to try and serve, rather than trying to serve the entire area. So for a fixed network, this can give you a more efficient design than trying to cover the entire area. We should also point out that we have automatic channel assignment functions, both for multi-point fixed assignments or for across an entire area. If you want to assign channels to your APs in the best pattern to mitigate any potential interference, you can do it that way on an area-wide basis. I'm sorry, that automatic frequency planning would be here under Wi-Fi if we're doing that for an area-wide basis. Or if we want to do it for a fixed network, we can do assigned servers and channels here under multi-point. So in that way, I can take my fixed list of subscriber devices and my list of candidate locations and have the software very quickly go through and look at the coverage footprint of all the candidate sites and say, okay, here are the locations where we should create APs in order to reach the percent coverage that you were looking for. And so if I've done that, now I can get rid of my candidate tower sites, and I've just got those fixed locations and the APs to serve them. And now we're at the point where we need to add some studies. And under both area studies and multi-point studies and route studies as well, you've now got this Wi-Fi system category where we can choose from any of the different Wi-Fi studies here. Most importantly, are going to be the downlink and uplink data rate. So this is megabits per second deliverable according to the link budget and the adaptive modulation table and system profile you've set up. There are also, handoff region studies, carrier over interference plus noise for best channel, all the kind of typical studies that you might use if you're really drilling down into understanding the performance of a Wi-Fi network. And the new one that I want to point out, and this is new for Wi-Fi, 4G and 5G LTE, as well as the WiMAX wireless broadband module. If you're using like Cambium equipment, Cambium broadband equipment, or a WiMAX type solution, any of those technologies are required to make these BDC filings with the FCC, where you show your coverage area according to the FCC's requirements. And if you filed for broadband data or rural broadband funds, and there's different reasons why you might be required to file these studies. And there's two versions of this cell edge coverage study that basically what we did is set up a study that exactly conforms to the requirements for the FCC to run these studies, because otherwise you would have to set up a couple different studies in Signal Pro previously and set everything up very carefully to make sure that it matched what the FCC was asking for. And so, this wonderful document here, the broadband data collection specification, gives a whole bunch of requirements for how those studies need to be run. And what we did is here under the basic studies, we've got a basic cell edge coverage that this will work whether you're looking at Wi-Fi, WiMAX, 4G, or 5G, or even a combination thereof. It'll give you basically a covered or not covered, yes, no type of coverage map. If we jump into the Wi-Fi system group, the difference in this Wi-Fi cell edge coverage is that, well, you can only have the Wi-Fi technology included. And what this is giving you, it gives you the same pass, no pass, but anywhere that it's a pass, it actually reports the RSSI at that location. So areas that, show as not covered, well, you don't have any coverage. If you want to look at the RSSI within that BDC coverage area, you can use this cell edge coverage study. And that's really useful because you really don't want to be looking at areas that you don't technically cover when you're, pre-qualifying customers or any of that kind of thing. So those cell edge coverage studies are a really handy way to say, okay, here's the coverage level within only the area that we technically can say we cover according to, the government. And so in this example here, what I did was to go ahead and place my APs using the automatic site placement for multi-point. And then I added my uplink and downlink data rate, my basic cell edge coverage, just to get a pass, no pass, and then my strongest server plot using best channel so that I can see how the channelization scheme would fall out on kind of an area-wide basis. So, here's, I'm going to show some of these study layers. Here's my best channel plot. This is roughly sort of the coverage area of each of these APs. And you can see it's not straightforward. These coverage footprints don't look like perfect circles. And that's because this area is so hilly and there's so much tree cover that the coverage can be a little counterintuitive. If I look at my downlink data rate study, of course, I've got areas that are kind of down in a hole that I really can't cover very well. And of course, the uplink picture looks worse. The uplink is always the hard case in Wi-Fi, or I should say almost always. And then that cell edge coverage study, that's just as simple as this. You know, if I show this on the status bar, I've got just covered and not covered areas. And maybe those studies in an area-wide basis are useful for, again, pre-dimensioning, estimating, or even in a live network, you could use that for customer sort of pre-qualification. But if we're doing a fixed design, really ultimately, I'm going to want to set up these multi-point studies and run those. And when I go in to add a study here, I've got, again, the Wi-Fi system category and all of the different study types that were available under area studies. And I can run these based on either just the strongest server, which will just run them automatically, or if I have run a channel assignment already so that each of my CPEs has a channel and a server assigned, I can tell it to explicitly use that. And one of the handy things about using the assigned server for a live network is that if you've got CPEs that are assigned to some other server for whatever reason, you know, you can mimic what's happening in the field and force it to communicate the way you see it happening in the field, regardless of what the predictive model says. So when I run those multi-point studies, of course, I get, you know, specific, here, let me only show the study layer and set for status bar, or set as current study. And then I can show my link lines here. And just like I said, you can see some really, really counterintuitive paths here where like this CPE, for example, right in here is communicating to an AP that's quite far away from it. And the reason why is that view shed. Here are my calculated results for that CPE. And then if I look at the path profile, it's because I just so happen to have line of sight all the way out to that AP. And that's the kind of thing we're seeing a lot, especially in really hilly deployments, is that you might get longer coverage distances that you expect in hilly areas, but it's very scattered. You know, you get basically a very large spread of coverage distance, where in some cases, you know, some of these sites have very little coverage at all, and they were only required to get me to the percent coverage I was asking for. You know, this guy here is serving one subscriber. And so in the end, I might actually remove those and see if it's possible to connect to anything else. And so let's see here. Let me pause for 1 second and just check my notes. Yeah, okay. So with these, once I've run all these studies that are the performance criteria, of course, I can go and query those using the study queries to say, you know, here's what percentage of the area or subscribers I'm covering within a given level. I can get all the, you know, results to each of my CPEs, as well as the azimuth and elevation back to the server. And those are all sort of the deliverables that I might have from the planning. But then there's some additional stuff you would want to do for Wi-Fi. We talked about the BSSID conflicts, and you'd potentially want to do some neighbor lists as well. So if I go into my network design Wi-Fi, let's take a look first at the BSSID conflict dialog. So as I was importing my sites, or as I create my APs, a bunch of these were just created with a template, so they have no BSS ID yet. But I went through and put some fake ones in so that I could show how the conflict search would work here. And so if you've got a live deployed network and you put in those BSS IDs for all of your sites, there are circumstances under which some of the APs might actually have the same BSS ID. And that can be a problem if their coverage footprints overlap and you can get into a sort of a conflict there where they're effectively interfering with each other. And so what I've done is I intentionally gave myself a couple sites that do have conflicts. So I put the same BSS ID in for a couple of these. And here, let me fatten up this line so you guys can see it a little better. And this display that you see down at the bottom here is just showing the locations of the two sites that have a conflict, and based on the site size that we put in here. So I pick a nominal cell distance or distance to cell edge so that there's not a lot of calculation time in this. And if there's a possibility that they're going to overlap and there's going to be a conflict area, that's what we're showing in sort of this Venn diagram as well. Here's all the area where you could have conflict by setting those to the same BSS ID. Just as a different example, if I go to this other one here, what I did is set these two to have the same BSS ID, but they're on opposite ends of the network here. So that would be totally fine, assuming, again, if I have potentially a large distance to cell edge because of the hilly nature, I might expand that out and say, well, if I get past 2.5 kilometers or so, then there's a possibility of conflict. That seems pretty unlikely. So that can help me make a decision about which conflicts are allowed. And if I decide I'm okay with this one, like, okay, they're far enough apart, I'll go ahead and allow this conflict, I can just move it down to that dialog and it won't show up in my list of problem conflicts anymore. Because there are circumstances where those conflicts are allowed, especially if you're looking at more of a small scale campus or in-building network. And speaking of in-building, I'll get to that in just a moment. So that's the BSS ID conflict resolution dialog. And then the other feature that you've got here is the neighbor list function, which basically you set the maximum distance and RSSI, choose the groups you want to look for, and then you can set the minimum area overlap for both these different kinds of frequency conflict. And then when I run this, basically it's going to produce these tables for the neighbor listing. And then I won't run it now because it'll take a little while to work out the propagations and stuff. But that neighbor list is one of the deliverables that you would usually have and want to keep on hand, is at least a predicted neighbor list. So let me check my bullet points again here. Okay, yeah, I guess I should say as a segue of getting over to the indoor stuff, the propagation model, we will support any propagation model in Signal Pro with the Wi-Fi studies. So if you're doing a large scale outdoor coverage area for example, broadband to homes or industrial Wi-Fi, such as, mining sites and that kind of thing, delivering Wi-Fi across an industrial area. We can use all of our typical outdoor models that we would use there. Or if you're doing an outdoor to indoor campus environment, of course, we can use our Anderson outdoor to indoor propagation model, or the simplified indoor model if we're doing a fully indoor project. And let me go ahead and, like I said, I'll segue over to an indoor project now. And I picked something kind of simple and basic. Yeah, arrange my view here a little better. So here I've got a really basic design here where I've got, oh, something happened there. I don't know what. I was messing with my Zoom stuff in the background, and it crashed on me. It's Murphy's Law, right? If you present something, that's when you get problems. Huh. Well, perhaps I'd better open a different project. It seems like I've got something wrong with that one. Let me try this. Sorry about this. The problem with this Durham Hall one is that I can't recalculate on the fly because it's a big complex building and takes, 10 minutes or so to complete a study. So hopefully this won't take too long to open and load up here, and we can take a look at it anyway. Oh, and I need to update. Well, shoot, I guess I can't show finished study results because it would just take too long to calculate. But what I was hoping to show here is that if you have both the DAS design module and the Wi-Fi module, so I've got Wi-Fi and I've got DAS, any of these Wi-Fi studies or features that I just showed for the outdoor use case can be done in an indoor use case as well. And what I've got here, this Durham Hall is a classroom building on the Virginia Tech campus. And this building model that we're looking at here came from AutoCAD DWG floor plans. So in other words, the AutoCAD drawings of each floor plan, we imported those, cleaned them up a little bit using our building editor tool. So I would start here with building editor, import those floors from DWG and create this building model. And the main thing there is taking out extraneous stuff that might be in that floor plan drawing. Like, for example, this staircase here, I don't want each of those stairs and the arrows and stuff to be regarded as solid walls. So we have a tool in the building editor to just throw all those items into a group and set them to an RF transparent reference material type so that they don't interact with RF. They're just part of the picture that we see. And I did the same thing for the door sweeps, and I took the elevators through the middle of the building here, and I changed those to be a solid metallic obstacle, so to model the steel elevator case and kind of the additional signal blockage that you get from that. And then I put glass as the material type for the exterior glazing here. And then when I set up my equipment under my building equipment list, for Wi-Fi, it's real simple. Most of the time, we don't need to do cabling out to a bunch of individual antennas distributing stuff with RF cables and splitters, we just use access points. You know, if I'm using the Cisco Air, for example, I can choose one of those. And if your equipment is not included in these tables, it's very, very simple and straightforward to add customized equipment into these lists. And that custom equipment will be available in subsequent projects as well. So it's easy to customize these tables of equipment if you want. And so I would choose those access points and drop them down here. Oh, sorry, that's my access point button. I would drop those down here on the map, just, you know, plug and play that way. Or again, I could create a list of candidate access point locations across this building and have it go through and select a collection of candidates to try and get coverage across the building. That automatic site placement feature works with either outdoor or indoor propagation models and use cases. So if we're trying to cover the inside of a building and there's a bunch of known locations where you could put an access point, we can plug those in and let the automatic site placement go. Or if we just want to let it go freehand and just place antennas where it will, the trick to do that is under my tower and poles database here, I can actually create an even grid of points at some point spacing. And so, you know, I'd go maybe every 2 meters or so around or within the polygon footprint of this building and just have it create a bunch of dummy points. And then when the automatic site placement looks at that, it'll choose from among those points and pick sort of roughly where the APs should go. And of course, the resolution of those candidates is, if you're willing to spend more time with more candidates, it might get a little bit better placement of them. But we can use those features here as well as any of the study types. And one thing that's important to call out for the DAS module in general and working with the buildings is that we do calculate coverage between floors. So in this model here, to make it run faster, I've got the only displayed floor transmitters are active. And so if I run my study, it's just going to run them for the APs and walls on this floor. If I set, like for my finalized studies, if I set the all transmitters active, both for coverage and potential interference, it will be looking at all the transmitters and doing the through the floor penetration prediction, path loss prediction, so that any coverage from an AP on the lower floor, for example, would be scaled down and show a smaller footprint because of the loss incurred in coming through the floor. And then, I would set up all the study criteria, the study types I want to see, most importantly, data rate, and run those so that I can say what percentage of the indoor area is covered at a given signal level. If this is a campus-wide design, and this building is, situated in the real world, as buildings often are, then I could also, for example, use the Anderson outdoor to indoor model. And if I've got an AP placed up here on the roof of this building, I could look at how that signal would come in through the glass and walls of the different floors of Durham Hall here, and I can include potentially that coverage as part of my design. That in that way, you can do a campus-wide design that will look for foliage, buildings, and terrain obstructions when the signal is outdoors. But as soon as the signal passes into that first exterior wall of a building, it transitions into our indoor simplified model so that you'll be able to see how outdoor signals get into the building and vice versa. my APs inside the building here, you'll see signals spilling out of those into the surrounding area, which can be important both from a coverage and a potential interference standpoint. That's what I have. I'm sorry I don't have finished Wi-Fi results I can show you right this minute. But if you've got an indoor use case that you'd like to look at for Wi-Fi, please do reach out to us, and we can help you get through the process of creating that building model and setting everything up appropriately. In terms of the equipment setup, it's real straightforward. We just like we did on the outdoor project, we choose the system profile and the adaptive modulation table we want to use, choose a channel plan, and then start placing APs, and then we can do our channel planning and our BSSID conflicts and all that sort of thing. That's what I had to show you. I guess if there are any questions, we've got a fair number of our attendees, so we won't just open it up to audio questions and the pandemonium that entails. If you've got a question for us, if you could go ahead and just open the Zoom chat and type that question in the chat. Rory, if you could maybe take a look and field those questions. I guess I can open my chat window too, can't I? And this can be any questions on anything Wi-Fi related. I can jump back to my outdoor project as well.
Hey, Brian, we did have a question come in. It's around, does the auto AP placement work on indoor locations like it does for outdoor?
I'm sorry, could you repeat the question, Rory?
Yeah, does the auto AP placement work on indoor locations like it does for an outdoor project?
Yeah, it does. If you, the difference there a lot of times is that you may not have a list of the candidate locations when you're in building. Sometimes folks do, and that's fine. We can work with that. But usually the extra step, if you're already familiar with the outdoor automatic placement under, auto placement for areas, the extra step that we would do in a DAS indoor project is just to go under towers and poles and use that create grid of points to just dummy up a bunch of candidate points on the floor that you could use if you don't know exactly where those candidate locations are going to be. Are there any other questions about anything at all? There's one comment that we'd like to see a follow-up webinar showing the characterization of interference due to indoor signals spilling into adjacent outdoor space. That's a great topic, and it would take a little bit of setup on my part just to to create a campus of buildings and put some APs in it and sort of show the potential for that interference. And that's a great question. It's a great coordination that needs to be done, because oftentimes indoor APs might be set up sort of willy-nilly. People might just toss them around anywhere and plug them in inside. So being able to plan that and look at how it's going to impact those outdoor systems as well is an important one. And like I said, do feel free to reach out to us, and we can follow up on that either individually, or we might go ahead and set up another webinar down the road here to talk about that kind of thing. And there's also a question here whether we're going to be distributing the recording, and yeah, I believe we'll be sharing the recording link after this is done, right, Roy?
Yes, typically this gets posted out to have access. So there should be something coming your way so that you have access.
We've got another question about how the study displays in 3D indoors. And gosh, I wish I wasn't having trouble opening my project with the completed studies. Basically, in the indoor use case, our 3D display capabilities are still kind of limited, to be honest. What we do is most of the time you're looking at a top-down view and we're displaying the coverage in a flat plane at that height. If you were to go into your map view and adjust the angle of it so that you're looking at it in 3D, what you're going to see is a 3D wireframe of the building, and that coverage plot is still going to be plotted as a flat plane sitting at the height that it sits on that floor. We don't have sort of a 3D cloud kind of a coverage map yet for indoor spaces. But so the short answer to that is that we display flat planes of signal results on the floor, even if you tilt it over on edge. Okay, well, if there are no other questions at this point, I guess I can give you 10 minutes back here at the end of the session. And, you know, like I said, please do feel free to reach out to us, whether you're a current Signal Pro user or considering the software, and whatever, you know, what modules you have. Please do reach out to us if there's a Wi-Fi use case you're looking at and you want to know how we would address it, whether or not you really need a particular module in order to address the deliverables that you need at this stage. And we'd be happy to talk through that in person. Oh, there's one last question here, whether the green link lines reliable or desirable to show on a map. As far as the display settings here, you know, I kind of displayed mine where the dark green is the good color, and the here, let me hide my Bing map. The, you know, going toward red being the bad colors, red and orange, and all of that's completely user configurable. If you want to set up these displays to use a different scheme or change how the link lines are displayed, you can do all of that. Any other questions? I don't want to cut anybody off before they get a chance to type it in. Okay, well, that's just about all I had. Thanks everybody for your attention and joining today. And Rory, thanks as well. Did you have anything you wanted to add at the end here, Rory, or are we pretty much set?
Yeah, I just wanted to say thanks everyone for joining. And as Brian mentioned, you know, if you are a current or prospective customer looking at Wi-Fi use cases, or you have any specific Wi-Fi use cases you want to see, you can reach out, whether that's direct to your account manager, or you can email sales@edx.com, and we can make sure that we connect you to the right person and get any other questions answered. But thanks again, everyone, for your time.
Yeah, thanks everyone. Have a good day.